Is it a good practice to use try except else in Python? From time to time in Python, I see the block. What is the reason for the try except else to exist? I do not like that kind of programming, as it is using exceptions to perform flow control. However, if it is included in the language, there must be a good reason for it, isn't it? It is my understanding that exceptions are not errors, and that they should only be used for exceptional conditions. For example, I try to write a file into disk and there is no more space, or maybe I do not have permission, and not for flow control. Normally I handle exceptions as or if I really do not want to return anything if an exception happens, then
I do not know if it is out of ignorance, but I do not like that kind of programming, as it is using exceptions to perform flow control. In the Python world, using exceptions for flow control is common and normal. Even the Python core developers use exceptions for flow control, and that style is heavily baked into the language, i.e. the iterator protocol uses stop iteration to signal loop termination. In addition, the try-except style is used to prevent the race conditions inherent in some of the look-before-you-leap constructs. For example, testing os.path.exists results in information that may be out of date by the time you use it. Likewise, q.full returns information that may be stale. The try-except-else style will produce more reliable code in these cases. It's my understanding that exceptions are not errors. They should only be used for exceptional conditions. In some other languages, that rule reflects their cultural norms as reflected in their libraries. The rule is also based in part on performance considerations for those languages. The Python cultural norm is somewhat different. In many cases, you must use exceptions for control flow. Also, the use of exceptions in Python does not slow the surrounding code and calling code as it does in some compiled languages, i.e. Python already implements code for exception checking at every step, regardless of whether you actually use exceptions or not. In other words, your understanding that exceptions are for the exceptional is a rule that makes sense in some other languages, but not for Python. However, if it is included in the language itself, there must be a good reason for it, isn't it? Besides helping to avoid race conditions, exceptions are also very useful for pulling error handling outside loops. This is a necessary optimization in interpreted languages which do not tend to have automatic loop invariant code motion. Also, exceptions can simplify code quite a bit in common situations where the ability to handle an issue is far removed from where the issue arose. For example, it is common to have top-level user interface code calling code for business logic which in turn calls low-level routines. Situations arising in the low-level routines, such as duplicate records for unique keys in database accesses, can only be handled in top-level code, such as asking the user for a new key that doesn't conflict with existing keys. The use of exceptions for this kind of control flow allows the mid-level routines to completely ignore the issue and be nicely decoupled from that aspect of flow control. There is a nice blog post on the indispensability of exceptions here. Also, see this Stack Overflow answer. Are exceptions really for exceptional errors? What is the reason for the try except else to exist? The else clause itself is interesting. It runs when there is no exception but before the finally clause. That is its primary purpose. Without the else clause, The only option to run additional code before finalization would be the clumsy practice of adding the code to the try clause. That is clumsy because it risks raising exceptions in code that wasn't intended to be protected by the try block. The use case of running additional unprotected code prior to finalization doesn't arise very often. So, don't expect to see many examples in published code. It is somewhat rare. Another use case for the else clause is to perform actions that must occur when no exception occurs and that do not occur when exceptions are handled. For example, another example occurs in unidist runners. Lastly, the most common use of an else clause in a try block is for a bit of beautification, aligning the exceptional outcomes and non-exceptional outcomes at the same level of indentation. This use is always optional and isn't strictly necessary.
What is the reason for the try except else to exist? A try block allows you to handle an expected error. The except block should only catch exceptions you are prepared to handle. If you handle an unexpected error, your code may do the wrong thing and hide bugs. An else clause will execute if there were no errors, and by not executing that code in the try block, you avoid catching an unexpected error. Again, catching an unexpected error can hide bugs. For example, the try except suite has two optional clauses, else and finally. So it's actually try except else finally. Else will evaluate only if there is no exception from the try block. It allows us to simplify the more complicated code below. So if we compare an else to the alternative, which might create bugs, we see that it reduces the lines of code and we can have a more readable, maintainable, and less buggy code base. Finally, will execute no matter what, even if another line is being evaluated with a return statement. Broken down with pseudocode. It might help to break this down in the smallest possible form that demonstrates all features with comments. Assume this syntactically correct, but not runnable unless the names are defined. Pseudocode is in a function. For example, it is true that we could include the code in the else block in the try block instead, where it would run if there were no exceptions. But what if that code itself raises an exception of the kind we're catching? Leaving it in the try block would hide that bug. We want to minimize lines of code in the try block to avoid catching exceptions we did not expect, under the principle that if our code fails, we want it to fail loudly. This is a best practice. It is my understanding that exceptions are not errors. In Python, most exceptions are errors. We can view the exception hierarchy by using PyDoc. For example, in Python 2. Or Python 3 will give us the hierarchy. We can see that most kinds of exception are errors, although Python uses some of them for things like ending for loops, stop iteration. This is Python 3's hierarchy. A commenter asked, say you have a method which pings an external API and you want to handle the exception at a class outside the API wrapper. Do you simply return E from the method under the except clause, where E is the exception object? No, you don't return the exception, just re-raise it with a bare raise to preserve the stack trace. Or, in Python 3, you can raise a new exception and preserve the backtrace with exception chaining. I elaborate in my answer here.
Python doesn't subscribe to the idea that exceptions should only be used for exceptional cases. In fact, the idiom is ask for forgiveness, not permission. This means that using exceptions as a routine part of your flow control is perfectly acceptable, and in fact, encouraged. This is generally a good thing, as working this way helps avoid some issues. As an obvious example, race conditions are often avoided, and it tends to make code a little more readable. Imagine you have a situation where you take some user input which needs to be processed, but have a default which is already processed. The try column ... except column ... else column ... structure makes for very readable code. Compare to how it might work in other languages. Note the advantages. There is no need to check the value is valid and parse it separately, they are done once. The code also follows a more logical progression. The main code path is first, followed by if it doesn't work, do this. The example is naturally a little contrived, but it shows there are cases for this structure.
See the following example which illustrate everything about try except else finally. Implement it and come by.